Hello, academic stars around the globe. Welcome back to Caltex Academy. If this is your first time visiting this great channel, you're most welcome, and my name is Julius. So today on our board, we are looking at time zone. Before I give you some worked example, I first needed to walk you through some few notes here and introduction. So I also strongly advise you to take some notes. If you don't have a notebook, don't worry, I have a good news for you. I've prepared a printable PDF cheat sheet, and the link is in the description of our video here. You can go ahead and download and follow along from there. So with all this said, if you're excited just like me, come closer and let's dive into the video. So we have this note that says, the world is divided into two zones, which are measured from Greenwich meridian 0 degrees. From our globe here, this is the line 0 degrees Greenwich, passing from the pole, that is North Pole, through many countries here, and then to the South Pole here, and it's at 0 degrees. The GMT system of measuring time is starting from this either to the eastern side or to the western side. And we realize that if we measure time in the western hemisphere, we always lost time. And if you measure time from 0 degrees to the eastern part, we gain time. That is good note for us to also take. And the next point we need to also know here is to see how we can convert degrees to time. So the Earth rotates on its axis and makes a complete revolution of 360 degrees in 24 hours. Therefore, we need to get how many degrees are there in 1 hour. So if you divide 360 degrees by 24, you realize that we have 1 hour is equivalent to 15 degrees. So with all this small introduction, let us now have a look at question number 1. Remember, I have 2 questions for you, so sit back and watch me doing it for you. And in case of any question, please don't hesitate to drop it in the comment section. I'll get back to you as soon as possible. So question 1 says, Japan is on a longitude of 120 degrees east. What is the local time in Japan if it is 04:15 hours GMT? So this is easy to deal with. What we have to first do is to get the angle difference between the two longitudes. One is this one here, where Japan lies, and the second one is the one from Greenwich, which is 0 degrees. Let's get the angle difference between the two longitudes, that is at 120 degrees east and Greenwich meridian. So we have angle difference is given by the result of subtracting 0 away from 120 degrees. So this makes no change. We have still our 120 degrees. So after that, we need to convert these degrees here to time. And from what I've just given here, we know that 1 hour is equivalent to 15 degrees. So what we have here is 120 degrees. What is that degree in hours? So we can cross multiply x with 15 and 1 by 120 degrees. Let's get enough space. And when we multiply the two from the left hand side, we get 15x. This must be equivalent to 120. So before we divide both sides, we need to also write one more step so that the division will be in its separate step. So 15x equals 120. Now dividing this by 15, also here by 15, and the 15 here cancels. So we're left with only x this is equivalent to 8 hours. Why do I say hours? Because you can see from here that our x is in the side of where the hour as a unit is. So this becomes our unit here. Now, the next thing is now to get exactly the time in which Japan is located, and that is the local time. How do you get the local time? Since Japan is in the eastern of Greenwich Meridian, then it must gain time. Therefore, let's have our time given in Japan from GMT here, that is 4:15 hours, and we add our time we've just gotten here. So we have 0, 4, 15 hours plus our time here. I need to write in the same way. That is 08. And these are exactly hours. We don't have minutes here, so we can also put there 0800 hours. And the next thing is adding these two together. And when you sum this together, realize that we have here 15 hours. Remember, I started adding from here simply because I know there's nothing that can add that will require us to add something from this hour system. So this is the local time in Japan, when in Greenwich we have our time system as 04:15 GMT. And I hope we're getting together well. In case you have some question, go ahead and put it in the comment section. I'll get back to you as soon as possible. So if I've also gotten some value from this video, go ahead and subscribe to the channel, like this video, share with friends. Remember, sharing is caring. And let's move on to question number 2. In question number 2, it says, in the diagram above, town F is on longitude 75 degrees west. So we can see from this globe, 75 degrees west is where we get our F here. A is on a longitude 0 degrees. So A is here, and this is our longitude. I think the degree is not given, so we can go ahead and indicate it here that this is 0 degrees. And that is our Greenwich. B is on a longitude 42 degrees east. Now, this one is our B in the eastern hemisphere, as shown by the degrees here, 42 degrees east. And C is on a longitude 60 degrees east. So C is here, that is where the longitude is, and it is indicated here as 60 degrees east. Calculate the local time at C if the time at A is 2 hours. So what we're required to calculate is time at C. And where is our C? This one. So what we have to do is to get the time difference between A and C, because A is our reference point at 0. So if I have this angle as theta, angle theta is the difference between the two longitudes at which C is and A is. So how do you get this angle difference? They are in the same system here, so we have to subtract the degree at A away from degree at C. So let's say the angle difference theta is calculated by subtracting 60 degrees minus 0 degrees. And of course, it remains unaffected because 0 will have no effect. We just subtracted nothing away from 60. Now, after getting this, the next thing we have to do is to convert these degrees into hours. I think we can even go ahead and work it in this free space here and say, okay, 1 hour is equivalent to 15 degrees. So here we have 60 degrees. This must give us maybe a certain letter y. Now we can cross multiply as we have done it before, and we have 15 by y we just simply get 15y is equivalent to 60. Maybe you can ignore the degrees because we just need to work without. Now the next is dividing both sides by 15 in order for us to get y alone. So here, the right hand side also 60 by 15. So the 15 crosses off and we get our y as 4 hours. Now the last step here is to get the time. And we learned earlier on that if you move in this direction, remember A is here and I'm moving in the eastern direction to locate our C, we gain time. And since time is gained, then we have to add these hours to the hour which has been given for us here. So let's get our time here by adding them together because we have time gain. So let's get more space to work this out, and we have 0 to 0 hours. We have to write in the same way. So we have here 04, 00 also hours. So since it is time gain, we also sum together and we obtain our results as 06, 00 hours. What does this mean? It means that if the time at A is 2 hours, then the time at C must be what? 6 hours. So for that case, that is how time zone works. So let's move on to the next question, that is part B, and it says, well, to calculate the local time at F, and our F is this line here, this longitude, if the time at A is 10 hours. So our time A here is 10 hours. Now, remember, this time we're moving in that direction, that is western direction, so there is time loss. So the first thing we have to do also to get this difference in our angle of the longitude, and we have here, maybe you can call this one here as an alpha. Now, after getting this time difference, then we convert it also into hours, then we subtract it away from the time given for us here because we're moving in the western hemisphere. So let's do it right away here, and our time difference alpha is given by subtracting 75 because that is where F is located, degrees minus 0 degrees. It remains the same, so our alpha is equivalent to 75 degrees. So from here, the next step is converting. So we had 1 hour giving us 15 degrees. Then we can say here that W is the unknown. So we have to also do what? Cross multiply such that we get the left-hand side of this expression. Maybe before that, we need to get some more space. And we have 15 W must be equivalent to 75. And from here, we can divide both sides by 15. So let's write an extra step, and we have here 15 W equals 75 over 15, also here over 15. Now, as we cross this out, we'll be left only with W from this left-hand side, and when you divide 75 by 15, we get 5. So we have here 5 hours as the time difference. Now, the last thing we have to also do here is to get now the time of F, given the time at A, 10 hours. So by doing so, we have to subtract away from time loss. So here we say time loss will be 10 hours minus 5 hours. Of course, we have to also put double figures here because that is how 24-hour system works. So we subtract, and we are left with only 5 hours. So you can see from here, if the time at A is 10 hours, then the time at F is 5 hours, meaning it is already morning hours, and here this is still night. So this is how we also calculate when we have a town located in the Western Hemisphere by simply subtracting. So finally, we have the last question that says where to calculate the local time at C if the time at F is 01:33. So looking at our globe, we're talking about C and F. And when you look at our diagram here, we realize that the angle difference is from here up to there, because that is where C is and this is where F is. And since they're located in different hemispheres, we have here the Western Hemisphere and we have here Eastern Hemisphere, then we have to add in order for us to get our angle difference here. Maybe somebody can call this one as phi. So let's move on with our phi, and we get angle difference between these 60 degrees east and 75 degrees west. Yep, so point C is phi is given by our 75 degrees in the Western Hemisphere being added together to 60 degrees. Now, when you add this together, we get 135 degrees. So from here, we can also convert this into our time. And so 1 hour gives us 15 degrees. So we have 135 degrees. We need to gain some time here. And maybe we can call this one as P. Now we can cross multiply, where P also multiplies 15 and 1 multiplies 135. So we get here 15P. This is equivalent of 135. Writing our extra step, we have 15P divided by 15, also 135 divided by 15. We cross out our 15 from the left-hand side, and we have P is equivalent of, if we plug this into a calculator, you realize that you get 9 hours here. Now, the final step is to add the 9 hours into the time given for us here. And the reason why we're adding is because this is in F. The time here at F is 01:33, and we're requested to get time at this here. And since it is in the Eastern, then we have to add our 9 hours to the existing time here. So let's go ahead and do it in our part here. So therefore we had what? Time gain. Therefore we have 01:33 hours plus 9 hours. So if we sum this together, we just simply get 10 here and 0 plus 33, we get 33, and our time is 10:33 hours. And this is exactly how we can answer questions related to local time in connection to GMT. So please support this channel by subscribing to the channel, like this video, and share with your friends. Remember, sharing is caring. So see you in the next video. Peace out.